So, hi, good evening, all. So, today we'll go through the introduction to data science and ML. So, what is data science? In simple terms, data science is the process of using data to understand the world and make better decisions. So, as you can see, the slide says it is an interdisciplinary field. So, which is just a fancy way of saying it's a mix of different subjects. So, the main goals are used to find hidden insights, look through all sorts of data that would include numbers, text, images to find interesting patterns or stories that are not obvious at the first glance. It would also include informed decisions. So that would be like use those insights to help a company, a hospital, or even a sports team that can make smarter choices. For example, if basically if Netflix uses data science to recommend shows you might like. So as you can see the diagram as well. So the circular diagram shows the key ingredients and the process involved in data science. So let's look at the three main skill area in the middle. So as you can see the computer science, that is the toolbox. So this is all about the tools that you use to collect, store, and clean up massive amounts of data. So you can't analyze clues if they are giant, right? Because they will be a messy pile. So that would include programming, that is writing code in Python to tell the computer that what it should do with the data, that databases and big data. So knowing how to manage and pull information from huge digital filing cabinets. Machine learning is also there because training a computer to find patterns and make prediction on its own as well. And as you can see, the mathematics and statistics. So that would be the rule book. So this is the knowledge that you use to make sense of the data and ensure your conclusions are trustworthy. So it is basically the rule for your investigation. This will include probability and statistics. That would include like basically figuring out if a pattern you find is like figuring out if a pattern you found is a real clue or just a random coincidence. For example, like is the new medicine actually working, or did the patients get better by chance? So that is also some kind of probability that is there. So that is just an example. Data visualization is also there because creating charts and graphs to see your data in a way that's easy to understand, because a picture is worth 1,000 points. Predictive modeling would be something like using math to build a model that can predict what might happen in the future as well. And as you can see, the domain expertise. So, domain expertise mean like you need to understand the subject that you are investigating basically. So you can have all the best tools and rules, but if you do not understand the context, then your insights won't be very useful. For example, if you're analyzing medical data, then you need to know something about the medicine, or else then it will be a waste, right? And if you're analyzing business data, then you need to understand economics and finance. And as you can see, the outer circle, that is the process. So the arrows on the outside shows the steps a data detective follows. So this is the scientific method that is applied to data. That is why observe and question. So you notice something interesting and ask a question about it. So why are our sales suddenly dropping? The hypothesis would be like you make an educated guess, or a hypothesis that would include like maybe our sales are dropping because a competitor launched a new product. That might be a case, or our product is not working as it should because of some outdated features that it has got, and the new product that has been launched has some very good features, and that is out boosting our product. That is also there. And like experiment could be done, so you gather and prepare the data you need to test your guess as well. Then that will include the analysis part, that then you use your computer science tools and maths statistics knowledge to analyze the data. So then you conclude, you figure out if your guess was right or not, and you share your findings with others so then they can make a decision. So basically, data science is the powerful combination of computer skills, math, knowledge, and real world expertise to solve problems and answer using the data. So, what is the machine learning? So, as we can see, machine learning is a subset of AI. So, that enables The systems will learn from data and improve their performance over the time. So you can basically think that ML is a type of AI that teaches computer to learn from experience, just like the humans do. So you can think of about how you learn to identify a cat. So you don't learn from a set of rules, right? That if it has a pointy ears and whiskers and a tail, then it is a cat. Instead, you learn by seeing many examples of cats. So that is how machine learning works the same way. So instead of programmed like with specific instructions for every task, but a machine is given a lot of data that would be the examples. Then it learns the rules and patterns from its own. The more data that he sees, the smarter it gets. So in short, you can think that it's about machine that can identify patterns and make predictions after learning from the data. For example, your email service learns to predict which emails are spam based on the pattern that it has seen in millions of spam messages. So the three types of machine learning, that is supervised, unsupervised, and reinforcement learning techniques. So the importance of data science, then we'll see. So as we already know that data is everywhere and data is a crucial part of today's world, and data science helps organization make data driven decisions, leading to improve efficiency and innovation. It also enables business to understand the customer behavior and market trends through the data analysis. And the insights derived from data science can also drive statistics initiatives and enhance competitive advantage that is there. And it basically that would include the competitive advantage would be like a car company might analyze traffic and pollution data to decide that building a new efficient electric vehicle for crowded city is a great strategic move that will sell better than its competitors cars. That is also there. So these are all the basic, you can say, the outcomes of and the importance of data science. And as you can see, they are 6 times more likely to retain their customers as well, the current customers, because they are much better at keeping their existing customers happy because they understand their needs, and 23 times more likely to acquire new customers because they are incredibly effective at finding and interacting and attracting new people who are a perfect fit for their products, and 19 times more likely to make a profit as well. So when you can keep your old customers and easily get new ones, so it's no surprise that you become far more profitable. So we'll see now about the data science process. So there are the 5 stages of data science process. So you can think of this process like preparing a special dish. So you can't just throw everything in a pan and hope for the best. So you need to follow the specific steps, right? The first step would include the collection. So what it is, this is the first step. So this is where you gather all the raw ingredients, that would be the data. The data can come from many sources like customer surveys, website clicks, sale records, or social media as well. So you can think of this like the perfect analogy for collection would be like finding and buying the best vegetables, spices, and other ingredients for your recipe. The second step for this would be cleaning. So what it is, so as you already know that raw data is often messy, so it can have errors, missing values, or inconsistencies as well. Then the cleaning stage involves fixing this issue to make the data more reliable. So the perfect analogy for this would be like washing, peeling, and chopping the ingredients. So you can remove any bad spots to make sure that the only best parts go into your dish. Third part is EDA. So that is basically now the data is clean, then you start exploring it to find the initial patterns, that would be the trends and interesting relationships. So this is done by creating charts and summaries to get a feel for what the data is telling you. So the perfect analogy for EDA would be like tasting the ingredients and smelling the spices, and you are just trying to understand their flavors to decide how to combine them the best. So ED is a crucial part because they are done by creating charts, summaries to get a feel that what the data is telling to you. Fourth step would be model building. So this is something like this is where the core science happens. So you use the insights from your analysis to build a predictive model by using machine learning algorithms. So this model can be used to make forecast or classify information. So the analogy for this can be taken as like actually cooking a dish. So you follow the recipe, that means the algorithm, right? Then mix the ingredients and apply heat to create the final product. So that is how the model building part is done. Then we'll see the model deployment. So basically what it is, a model is not useful if it just sits on a computer. So deployment is the final step of putting a model into a real world application, so then it can be used to make decisions, right? So it should come to an use. So that's where the model deployment comes off. And the analogy for this would be like giving the finish off, like the finishing should be nice. So plating the dish beautifully and serving it to your guests so they can just enjoy it. That is there. And the roles involved in this. So the data engineers are like basically they are the masters of data collection. They build the systems, pipelines that gather and store vast amounts of data efficiently. For data analysts, they specialize in cleaning and exploring the data. That is the EDA, exploratory data analysis. So they are the experts at creating dashboards and reports to the final insights. Learning engineers would include like they basically focus on the more technical stages of building the model, then deploying it into live applications so that they are ensuring that it learns smoothly. Data scientists are the versatile all-rounders. So, as the long bar shows, a data science has often the skills to work across the entire process, from the cleaning and analysis all the way building to deploying the models. So, the types of data. So, data can be classified into unstructured data, semi-structured data, and structured data. So, structured data is highly organized and easily searchable, but unstructured data is that includes like text, images, and it lacks a predefined format, so that can be messy. So that is how the unstructured data is. And as you can see, the unstructured data would include PDFs, JPEGs, MP3, movies, but structured data includes like relational databases, so they are already organized, maybe in a tabular form or something, because the structured data is the most organized type of data. But for semi-structured data, that is something like it is a mix of both. So it is not as much as rigid as the structured table, but it has got some organizational properties like tags or markers to make it easy to analyze that than the purely unstructured data. So it is a mixed match of both. And the example would be JSON, XML files, a CSV, and email as well, because it has got some structure as well. So the tools in data science would include the Python, R, SQL, Java, Apache Spark, TensorFlow, Git. For data manipulation and analysis, Python and R are used respectively. For data visualization, we use Tableau, Matplotlib to help communicate insights effectively. We can use Power BI as well, and other technologies are also there. And for big data, technologies like Hadoop and Spark are essential for processing large data efficiently. So you can see the introduction to data visualization. So data visualization includes the basically you are plotting the data into the graph. So it basically means the visualization of data in the graphical form to make the more complex data more accessible and easy for a normal person to understand the insights. And effective visualization also helps uncover trends, patterns, and outliers that may not be apparent in raw data. So you can use, as I've stated, Power BI, Tableau, Matplotlib are the most popular for creating compelling visual narratives. And these are the types of charts that can be made. And yeah, for different purpose, different kind of chart is being used. Now we'll see the different types of machine learning. That is, like, first is the supervised learning. So you can think of this like learning with a teacher. The machine is given the data that is already labeled with the correct answers. So the goal over here is for the machine learning to learn the relationship between the input and the output. So you can think a real world example would be like training an email spam filter to, because it is fed thousands of emails that have already been labeled as either spam or not spam. So that is how it is being done with supervised learning. So in this, basically, its learning involves on labeled data, so where each input comes with a corresponding output. And the algorithm that involves over here is linear regression, sorry, decision trees and support vector machines. And this is you, as I've stated, this is used for email spam detection, medical diagnosis as well. So now we'll see the unsupervised learning. So you can think of this like learning without a teacher. So the machine is given a bunch of data that is not labeled, and is asked to find hidden patterns or structure on its own. So, for example, you can think that if you give someone a box of mixed up Lego bricks and ask them to sort them, so they might sort the bricks by color, by size, or shape, but you cannot determine that how they are going to sort it. So they find the patterns themselves without being told what to look for. So this is something like an independent approach, and individualist approach as well, because you don't know how they are going to sort it. Some might sort them from the colors, some might sort them based on the patterns, or some might sort them based on the shape as well. So the real world example for unsupervised learning would be like a shopping website grouping customers with similar buying habits together to recommend products. So it does not know why they are similar, but it just sees the pattern in the data. So that is how unsupervised learning works. And it is done like, as I've given an example for shopping website, and it is also used in anomaly detection in security. And the techniques used in this would include clustering, dimensionality reduction are frequently employed in this category. Now here comes the reinforcement learning. That is something like, this is learning like through trial and error. So the machine learning learns by performing actions and gathering data. That means like getting rewards and penalties in return. So the goal over here is to figure out the best actions to take to get the biggest reward. So you can think of a like training a dog to do a trick. So when the dog does the trick correctly, you give it a treat, right? That means a reward. So when it does something wrong, then it gets nothing, a penalty. Over the time, the dog learns a sequence of actions that can lead to the treat. So you can think the real world example for this would be an AI learning to play a chess game. So it gets a reward for winning the game and penalty for losing, learning the best moves over the thousand of games. So that is how RL is done. And like, it is commonly used in robotics, game playings, and autonomous systems. And as I've stated, so it basically works on the reward and penalty system. So when the learning is successful, then it gets a reward, and if it does something wrong, then it gets a penalty. So that basically works on the give and take mechanism over here. So that is how RL works. And the most challenges in data science would be like, as we can see, the one major challenge in DS is data quality. So as poor data can lead to inaccurate conclusions. So if the data is not right and the data is poor, then everything goes wrong. Nothing can be done. So the from representation to training the model, because if the data quality is poor, then the model will also not learn efficiently, right? And the training will also go in waste. So that is why the data quality is something very important consideration in DS. And ethical consideration is also there because data privacy and bias in algorithms are crucial for responsible data use. And the rapidly evolving field requires continuous learning and adaptation to new technologies and methodologies as well. Because as we already know, that data science branch is a huge field and it requires constant learning and adaptation to technologies and methodologies as well. And as you can see, the most important challenges of data science that would include the number, like the infinite number of data sources as well, because business problems are not clearly identified. That is also a major challenge, because if the problems are not clearly identified, then we don't know what to like proceed with, right? So you don't have a aim as well over here. And difficulty in order to find skilled data scientists as well. Selecting the right tool is also important. Lack of data security, as I've said, the ethical considerations. Lack of business growth is also there. And a proper method to get value of data science. That is very much essential over here. So the major challenge that what I feel is that the quality of data remains the primary challenge without it, because nothing can be done. If the data is poor, then there is no use of, like, basically it goes in a waste. You cannot train anything because it will be biased. So data integrity is very much important over here. So then we'll see the future of data science and ML. So as we can see, the future, as we have discussed, that it involves many fields like data engineers, machine learning engineers have different roles, data analysts, like in like today we have AI engineers as well. So the future of data science and machine learning holds promise with the advancement in AI automation and predictive analytics. So emerging trends include the integration of AI in everyday application and the rise of expandable AI for transparency as well. So as the organizations continue to harness the power of data, the demand of skilled data scientists will only increase, because in the world of data, the data is only growing. So it is not going to stop. So this field is very promising, and the demand for skilled data scientists, data analysts, data engineers, and even machine learning engineers and AI engineers will only be increasing going forward. So now you can see the conclusion, because the data science and machine learning are just transforming industry by enabling better decision making through data insights. So solid understanding of the concepts, tools, and techniques is essential for anyone looking to enter this field as well. So embracing data-driven approach can lead to significant advancements in various sectors, including healthcare, finance, and technology. So this is how we conclude the introduction part. So, any questions? Any questions, guys?
No, ma'am.
No, man.
No
No, man.
questions. Okay, then that's nice. So, so we just went through the brief analogies what a data science field includes. So we will be going we'll be deep diving going forward on different technologies and different project related sessions. So over there you will get a brief overview how this field works and how the projects are gonna be, and you will gain experience upon that. So this was just a brief introduction of the terminologies.
Okay. Ma'am, when we will be assigned with the projects?
I think it will be done soon. Like the support team will reach out to you regarding this. But today was the introductory session, so I think it will be done soon. You will get the mails.
Is there any assets they will provide for us for that, or else
Basically, the assets in the sense like you're asking what? Can you be more specific?
assets in the sense like mail ID, company mail ID, or else data is requires privacy, right?
Yes, but
So
I am not sure. I don't think so.
projects like we are doing projects for open source data, or else
Open source only.
okay, open source only. Okay.
Okay. Then, if there are no more questions, then we'll conclude the session.
Thank you, ma'am.
Okay. Thanks for joining, guys.
Thank you.
Thank you.